Today's video will be talking about a binary tree, its implementation, and then the most common methods have the insertion, deletion, and then the transpose. Okay, so let's start. Firstly, we have binary tree. Now, what is a binary tree? A binary tree is a nonlinear data structure in where consisting of nodes where each node has the child nodes, which is the left child node and right child node. And in binary tree, each node has at most two children only. Like, for example, here we have this two. This two is a node, and this node can have at most two elements, not more than two. That is a binary tree. And for binary tree, there's only one condition that at maximum two children nodes. That there should be maximum two children. So this is the binary tree. So here we have okay. So we have this node. For this node, we have it has two children, one and two. Again, for this is the another node. It has again two children, one and two. And for this, it has one. So if there is one, it is still of one, like zero, one, and two. At most two, and like it can have like zero and one and two. So six has two children, and 9 has 1, and then 5, 11, and 4 they have 0 children. So this is a binary tree. So now as we move, so here we have this is a basic representation of the binary tree. So this is how we see that one is a root node. So uh, one is the base root node, and then we have two. So two is the parent of 4 and 5. So here, who is the parent? We have who is the parent that for 8. Who is the parent of 8? 4. And who is the parent of 4? Which is 2. Like 2 have 4 and 5. So that means 2 is the parent of 4 and 5. And 5 is the right child of 2 and 4 is the left child of 2. And then second. Yeah. This is like 4, 8, 5, 9, 10, and 7. These are the leaf nodes, and this is the representation we have. Like a root node will define again. Root node will be defining the node in our coding part. So what we'll be doing that A is we have the value, we have the node data will store, and then it has a left and then it has the right value. So in that left value, it has so in the left value, it has the address to the left child, and right value, it address to the right child. So this is like how we create the binary tree. After that, we have different types of binary trees. So first one is we have various types of binary trees. So after that, we will be studying some of them that is full binary tree and complete binary tree and all that. So first one is a full binary tree. So what is a full binary tree? That means it has either zero to children. That means it is full. It is not like one have only one child. So it's not like that. So in full binary tree, we can have here we have the example we take. Okay, so this is we have one element, and this is we have the child of it. So the left child, this is the right child, and right child again have this two child. It has one. This is two. This is two. This is we take three. This is we take four, and this is five. Okay, here we have. So in that, now here we have. Okay, so this one is a root node. This one is the root node, and this two is the child of one. So one has a child, two and three. Yes, okay. Well, we are go to each and every node and we'll check whether it is satisfying the condition of a full binary tree or not. And then we go to two. Two has two don't have any children. That means it is okay. We have not either zero or two. If there is one child, then it's not a full binary tree. And then three has two, and then four and five zero children. That means this is a full binary tree. Like so, like if I have one child or after two, then it's not. After that, we have a complete binary tree. So for complete binary tree, we have condition. None of the level is partially filled. That means in the binary tree, we will be considering levels. For example, we have this, And then in that, we have the second level. It has two child, the left child and the right child. And then this one again have the two child, the left child, and then the right child. And this one again have two child, the left child and right child. And this again have two. Just like that, they all have two child, the left one and the right one. So we'll check whether this is a complete binary tree or not. So for that, okay, this is the pair. This is the parent element. It has two children. This one and this one. So okay, this is level one, and this one is level two, and then we have this one. This is level three, and then this one. This is level four. We have four levels here. So okay, so this is the level. This whole is the level. And so we'll check that none of the level is partially filled. That means, okay, so it has the two children, both are there. So, for example, if I take that this is not here, for example, if I remove this one, now I've removed this one. Okay. Now I'll check if it is a complete or not, then it's not. Because here, this level is not completely filled. It does not have the right child. Okay, so we want the right child. If we have this right child, that means it is a complete binary tree. So then we move to the third one, which is the balanced binary tree. Okay, so what is a balanced binary tree? When the height of the left and the right node doesn't differ by more than one. So that is, we'll take the height. So what is the height? For example, it is 3 and 1. So when we are going from 3 to 1, its height is 1. And so going from 1 to 0, again its height is 1. So we are going from 3 to 0, then its height is 2. So like that. This is the height. So now this is the basic formula we're going to use. That is depth of the node is height of the left child minus height of the right child. So here, there is no left and right child, so its depth is 0 obviously. So now, for this one, here the height is 1 over there, this is 1 over there. So height of the left child minus height of the right child, so it's 0 obviously. And then here also again it's 0. And now for this, here we have the right child, side is 1 only. And for the left child, we go to the last child, that is this. So we have 1 and 2. We have this 2 over here. We have 2. So now we'll have the left minus, right, that is 2 minus 1, that is 2, its left is 2. So we'll check for each and every node. And if we have either 0 or 1 there, we get the depth either 0 or 1 for each and every node, then that is the balanced binary tree. And in this one, we have for 5, we have depth 0. So here we go, depth will become 1, that is so okay. There is no right child over there, there is only a left child, that is 1 minus 0, that is 1. So for 4, and we repeat all that up to 0. Now, in that for 0, we go to the last one, that is 1, 2, and 3. So in the left side we have 3, and the right side we have 1. So for this depth, we'll take 3 minus 1, that will be 2. So here we have depth as 2. So this tree is not balanced because what we want is not more than 1. So that's why it's a balanced one and it's an unbalanced one. Then we go to the operations of the binary tree. So as we learn the type, what is a binary tree and types of binary tree, we will move to the operations. The first operation we have here is insertion. We want to insert the values in the binary tree. We want to insert the nodes in the binary tree. So how do we insert? Firstly, we'll go and check. So in that, we'll simply do that. Firstly, we'll check that if there is any missing left child. If there is any missing left child, it will go to the left. And if there is any missing right child, it will go to the right. So now here, we want to insert a node 2 in the binary tree. We want to insert 2 over there. the binary tree. So this is 1, 3, and 6. Now we go there. Firstly, we want to see that which is there any left child missing. So now we go to the 1. 1 is the root. So now for that we will see that is there any left child? Oh, we cannot have a left child. So now we'll add the 2 over here. So if I consider that there is already a 2, then it will move, then it has a right child and left child. Okay. Then it will move to the 3. And then 3 will check if there's 6, then it has a left child, then we'll see the right one. If don't have a right child, then it will go here. So for that we have added 2 over here. We have added 2 because there is a left child missing. And then now we have added 2 over there. We'll get this one. And now we want to again insert the another element, that is I want to insert 7. So for inserting the 7, firstly it will go to the first node. And the first node it has both the children it has, that is the left and the right one. And then again it will go to 2. It doesn't have any children. So go to 3. 3 have a left node, left child. So now the right child is missing. That if you have a left child, you must have a right child. So the right child is missing, so it will add the 7 over here. So this is how you do the insertion. Like this is the basic approach of how you do the insertion, and rest will learn in the coding part. So keep this in the mind until we move to the coding part. So now for the deletion, we have deletion. Now we want to delete the element. So focus on this one, that we are when we are deleting. So here we will have that I want to delete the node 1 from the binary. I want to delete this. So what we'll do, firstly, we'll delete that node and then replace that node with the deepest node. Deepest node, that is the last node. For example, in this one. Okay. For example, we have in this node. Okay, here we'll have in this one, this is the deepest node. 4 is the deepest node over here. So now we'll delete that node and we'll replace it with the deepest node. So now if you want to, like, I want to delete 1 from the binary tree. We'll take this and we'll delete this, and then we'll take the deepest. And if, like, for example, if there are 2, sorry, okay, I'll take the example. Okay, here we have 2. Both are the deepest. Now, if we have 2, like both the left and the right child, and the deepest are deep, then we'll consider the rightmost. So now we'll consider the 3. We'll delete this element and replace 3 over here. And we'll replace 3 over here. So now it will become 3 and 4. And now for this one, we want to delete the node 5 from the binary tree. We want to delete node 5. Then for deleting node 5, we want to delete this one. So it is already the deepest node. So we don't need to do any. We don't need to replace anything. Just simply got deleted. And now we move to another one, which is delete node 2 from the binary tree. We're deleting node 2 from the binary tree, so we want to delete this one. So we'll delete this and we'll replace this by 4. So it will become like this. So after that, we'll move to the after deletion, we'll move to traversal. So in traversal, like we want to go through the all the nodes of the binary tree, and for that we have 3 types of traversal, which is the pre-order traversal, in order and post order. So what is that? Pre-order traversal will use that left right method. That means first we go to the root, go to its left, then go to its right, and then again go to root and we'll apply on each and every node. So now when we are doing the traversal, what will we do? That we start from the node root. So from root we'll go left, and then after going to the left, it will become the node. So now I will again apply the same thing until we got to the last element. That means for that we go to the end and then we go like this. So this is how we do it. So after the 2, it is the root, and then go to the left. And now this will become the root. So now it is the root, go to the left. So now we are in the left. Now we don't have any root, so it will complete it. Like root left, right. So 3 is the root, 4 is the left, 5 is the right. You got this? And then we'll come back to 2, and then we have 2, then we'll have 6 over here. So we'll go to the 6 and then we'll move like this. So after that we'll again go back to 2 root left right is done. Then again go back to the 1. 1, the 1 is the root, so we have left and then we have right. Right, but we have 7. Now, so right, in the right we have 7. So after the 7 we have root left right, we'll go to 8 and then 8 will become the node. And after the 8 we'll go to the left thing. So we'll again go to 7 and then we go to 9. And then after going to 9, 11 and then 12. So we'll do like that. So what will be our pre-order traversal? Pre-order traversal we'll have here. What will be the order of our pre-order traversal? That is 1, then 2, 3, 4, 5. After 5, what we had? 6, and then 7, 8, and after that we had 10, then 9, and then 11, and then 12. So like this is how I added the elements. So this is how we get our pre-order traversal. So this is how we move to the binary tree while we are doing the pre-order traversal. That is 1, 2, 3, 4, 5, then 6. After that we have 7, 8, 10, 9, 11, and 12. So we go like this. And after that we have an in-order traversal. So yeah. So in order traversal, again, we'll take in order traversal, we have left root right method, like almost similar to the pre-order, but it's just that it will start from the left. That means that 4 is our left element, then we start from 4. We'll go that's 4 left root right, left root, and then we come to the right, and then so for this one it is completed, and then we go to 2, and then we go to 2, so that is left root and then right. And then for the right we go to 6, and then we go to 1. So for this, we have so this whole was left root and then we go to right. So when we are going to right, we start from the left root, then we start from the 10. So this is left root and there is no right element. Then we'll go to the, sorry, wait a second, sorry. From here, we come directly to 10. We go from 8 and then we go to 7. We go to the 7th element, and after going to 7, we'll come left. We'll come to again the leftmost, that is 11, and then we go to the root and then right. So this is how you move in order traversal. So in order traversal, what will we get is in order traversal we'll get we start from 4 and then we have left, root, right. That means 4, 3, 5, and after that what will we have 2 and then 6. And after that we have 1. And then we have the we go again to the left part of now we have this whole is a different a binary tree. Like a binary tree has subtrees. So we're taking for every tree. So we start from the leftmost. So after 10 we go to 8 and then 7 and then 11, 9 and then we got 12. So this is our in order traversal for this. So after that we have post order traversal. So after that we'll have a post order traversal. Similarly, like in post order, we'll have left, right, root. So there's a like difference. So how do you remember? It's like pre is before, so pre in and post. Post is like after. So pre in post. So it's like root will come before first at the first position. So root at first. In order root at middle, and in the left one root sorry. The post order root is at the last. So it is like for three in fourth, that is first, like in the starting, in the middle, in the last. So for the post order, we have left, right, and root. So we have this, and that will start from the leftmost first, and then we have four. So in that four, left, right, and then root. So we'll go to 4, 5, and then root. So again, after this, we come to 3, then again left, right, and root. So after 3, we have 3, and then after that, we'll have left, right root, and then after again we going, we come back over here left. So there is no right to go directly to the root, and then there is no right. We go here at 7, go to 7, and then we have again we go to the root, then left, right, and then root. And then we again at the end we go to the first one. So we start from here and we ended at here. So in post order, what will we get? So the more you start doing the questions on it, you start understanding it. In the beginning, it may seem very difficult because as you keep on practicing, you keep on understanding it well, and you don't get confused between the post, pre, and how you do it. So in the post order, we'll have four, and then we start from the left, right, root. So in the left and the right, we have 5, and then root 3. Then we go again, that is, we are on 3, 3 is our, we are on 3, 3 is our root, so we have left, right, root. So for that, we have 3, after the 3, we have 6, and then go to root. And then we start going back, so we have left. So we'll find left of 1, and then left of left, we go to 10. So after that, we have 10. So left, right, root. So 10. After that, we'll have, so there is no right, so we'll go straight to 8. And then again, we go to 7 from that. 7. Wait a second. Wait. It will go to 7. Sorry. It will go to 8 first. From 8, it will go to the left, right root. So, wait a second. We'll have it, it will go from 8. So, we go from 10. I'm sorry, there's just a minor mistake. So here we are going from 10 to 8. So we have left root. And then after the root, we don't have right. So we go directly to the leftmost. So then we have 11 left, right, and then we have root. And then again we go to 7, and then we go to 1. So we don't go to 7 after 8. So it's like here when we are printing, so it's like after 8, I will have 11 and then 12. Then we have 9 and then 7. And after that, at last, we have 1. So this is what you get in the post order traversal. So as we have done all the traversal, now we can move to the coding part. Firstly, we'll be defining the node. So firstly, in the class, we have the nodes. We have class. We have the class tree node. And after that, we'll be defining init self, key. So here we have this attribute key. So key is like the data which you store over here. So in that we'll have uh, a left and a right part. So we'll have self dot left. So we'll initialize it as none. And then we have self dot right. Again we initialize it as, so we have self dot right. Self dot right. And then we have cell dot value which is equal to key. Okay, now we have created the class tree. After that, we'll start doing the insertion thing. First, we will be defining insert. So in that we want a root. So if we are defining the root, basically root is kind of like, for example, in the linked list, you are having you are setting the element. So it is the like current element. Keep it like this. So in that we have root over here. So it will first point on a root, like any node which is named a root in which you are in which you are inserting the left or the right element which you want, or in that you are inserting your element. After that, you are inserting left and right element. So we have root, and after that we have key. That means the value which you are inserting. Basically. So in that, firstly, if it will check that if root is none. Firstly, it will check that if the root is none. So like the root is none, that means that this tree is empty. So there's like no node in the tree already. So it will return tree node. Key. So if the root is none, so there is no root, it will start returning the key element which we have defined in the tree node. So after that, if root dot left. Now we have inserted a value in the node. We have inserted the value in the first node. First root node. After that, we want the left child and the right child. How we got the left and the right child? So if root dot left is none, that means if there is already no right child, value is none, then root dot left is equal to insert root dot left, comma, it will insert to the left. If root dot left is none, then it will insert the root dot left and key. So it will insert the left part, the key element which you want to insert, and same for the right one will take. Same for the right one will take that right and left root dot right is none, then root dot right will insert right, and then the key, and has like for example, if it has both the left child as well and the right child, what will you do? Then you will randomly put it anywhere. Like you will randomly you will apply the insert strategy. So we're doing import random. Now if sorry, import random if random dot, so we'll be taking any random values. We will have yeah, the ends. We'll have this. After that, we'll have root dot left is randomly putting value. Firstly, we'll put in the left one. Root dot left is equal to the space will keep it here. And then we have, and if not in the left side, then we move to the right side. Here we have root dot right is equal to insert root dot right, comma, key. And then here we have inserted the values. So this now you will insert, and if not, then it will simply return our root. So after that we'll have, now we have inserted, now we have we have defined the insert function. Now we'll be defining the deletion function. Will be delete, and we'll again take root and key as the attributes. We have taken root and the key as the attributes. So now if root is none, That means firstly it will check if there is a root or not. Root is none, then it will simply return root. Sorry. So we return root. Now if root dot value is equal to key, that means you find that the key which you want to delete. Key is here. In that key was the element which you want to insert. Here key is the element which you want to delete. So if this is key, then it will return none. After that we'll have change or end. So after that we'll have root dot left is equal to delete root dot left comma key. Again we have root dot right is equal to delete root dot right comma key. Key. Now we have deleted the this one. So now we have done for insertion and deletion. Now we'll be doing for pre-order for the traversal. Our first traversal would be a pre-order traversal. So we have pre-order traversal, and in that we'll be taking the attribute as the root. So now in that if so now when we are uh, putting the if statement on the root, so it will firstly print. Firstly, it will print the root value and then it will go how it will start root left right. So firstly it will print the root value and then it goes to the left and the right thing. Firstly it will print root dot value and then end. So this is basically this is given for space. Like I want one after that I want a space. So it's not like 1, 2, 3, 4, 5, 6. It's like 1, 2, 3, 4, 5, 6. I want like that. So for that I give end, then print and then I have three order reversion. In that pre-order traversal, firstly we'll have root dot left, root dot, then it will go to the like root left right. So it will go to root and then left and then right. It will go like this. Right. So this is for the pre-order traversal, and for the in-order traversal, everything would be same. Just so like in pre-order traversal, the only difference would be the so in that we have the root left right. In this we will have left root right. So that is the only difference in pre-order and in-order traversal. So we have in-order traversal. So here we have all things are same. We just have to change it. In-order traversal. We have in-order traversal. So firstly we will start with root dot left value. Firstly we'll start in-order traversal. We'll start with root dot left value. So only difference will here be. So first we start with left, and then value, and then right. So just like that, in post order. So in post order, what will be changed is like left. Sorry. Firstly, it was root left right, then it is left root right, then it is left right, and then root. root will go to the last one, so it will go to the last one. It will go after all, and then we change this in to post. Yeah, this is our post order traversal, and then it is firstly left, and then right, and then root. So we have done this in order and post order and all that. So now we'll be taking an example to understand it well. So in that example, firstly we will be initializing root as none, and after that we will be initializing root as none. After that we have the keys. We have the keyword. Key will be defining the key like 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 10, and then we have 11, and then we have 12. We'll take in these values. And then after that, we have 4 key and keys. We take one from them. Root is equal to insert root comma key. So we have taken one from them. So this loop will keep going from 1 to 12. It will first insert 1, then 2, then 3, then 4, and all that. So after that, we'll have, so I will be printing, we are printing pre-order traversal, that is pre-order traversal, pre-order traversal, that is, we have root over here. So just like that, we want pre-order, post-order, and all that. I'll copy paste it. This is for pre-order. This is for in-order, in-order traversal. So here again we'll write in-order. So here we'll have this, we had pre-order, we have post-order. Again we have post-order traversal. Now I want to delete one of those elements, and then I want the same traversal, like pre-order, in-order, and all that. So will be here will be deleting a node. Deleting a node, then we have delete, and then root. Okay, which one I want to delete? I want to delete. I'll say I want to delete 7. Okay, now I want to delete 7. Then we'll again print after deletion of the node with what was the value? 7. We'll have after deleting it, we'll again print the same thing. So same thing. So after deleting it, I'll start repeating the same again. That is pre-order, in-order, and post-order. So this is our code. So there is one code. So here, oh, so we don't have surrounding. So yeah, sorry. Go back again. Now, yeah, this one. So this was our pre-order traversal. This is our pre-order traversal. What is our pre-order? 1, 2, 5, 9, 7, 8, 3, 4, 11, 6, 10, 12. And then in order traversal, we'll have 9, 5, 2, 8, 7, 1, 11, 4, 3, 10, 6, and 12. And then we have a post-order traversal. This node value 7, and then we'll then print the pre-order traversal. And so this is how you do the in order, and then so this is how you learn the binary tree and its insertion and deletion in it. And after that, we learn the traversing, that is in order, pre-order, in order, and post order.